Today we are going to talk about growing open source DB ecosystem on ARM. I'm sure you are aware that ARM ecosystem is expanding and it is gaining quite good attraction. A lot of open source projects are already being ported to ARM, and including databases. But it is not only the mainline database, but along with the ecosystem that they carry, especially the supporting tools, are also being ported to ARM. So let's try to understand what is the state of these open source database, what is the state of the ecosystem, which all tools have been ported, what things you can expect in upcoming days. And of course, we'll try to understand importantly the performance aspect, what performance you could expect. And is it a right time and choice to consider ARM? My name is Krunal Bauskar, and I've been driving this MySQL on ARM initiative. Uh, that's quick intro about me. I have been working in MySQL space for more than a decade now. Currently, I'm working with Huawei as part of their open source DB group. In past, I've worked with Percona as PXE product lead, at Oracle as InnoDB developer, at Yahoo Lab as big data research engineer, as at Kickfire, which is now part of Teradata, where we develop the world's fastest MySQL storage engine, and more such things to add. I have been driving MySQL on ARM initiative, which includes all kind of MySQL database, MySQL, MariaDB, Percona, and other ecosystem tools. I speak at Percona and MariaDB conference, and of course I blog at the site. So with that quick intro about me, let's move on to our today's agenda. Sorry. So why ARM is gaining importance? We'll try to understand that, and then we will talk about which open source databases already have presence on ARM and what is the state of them, and then we will try to understand the ecosystem that is evolving around them, and then of course we will talk about the performance and cost, because that has been the key motivation factor for any end user to consider ARM. Then we'll talk about community support and how community is evolving, and then we'll end it out with some quick note about future work. So then let's get started. So why ARM is gaining importance? So what does it come to your mind when you think of ARM? I'm sure majority of you would think about cell phone and network equipment, and majority of our cell phones are powered by ARM. Now, if you stretch it further, you would realize that a lot of housing appliances and IoT devices also has ARM. And if you stretch it further, you would discover automobiles, defense, space has also quite a good number of ARM processors being used. In fact, with a growing number of self-driving cars and smarter devices, ARM is being used on wide variety of applications. What is something new is high performance computing. So when we say high performance computing, it typically includes software which needs really a good amount of computational power, whether it's a big data application or whether it's database or for that matter application servers. So this particular vertical was not, I would say, very frequently used, but now the ARM processors are getting more and more faster, and probably also there are more numbers of cores are getting added, they are getting more powerful. So this new vertical is getting opened, and of course the motivation behind it is the power per watt, or sorry, the performance per watt that ARM provide. As you all know that ARM consume pretty less power. Eventually it turns out to be a low cost of ownership, and that has been the motivation. And with ARM processor getting more powerful, it has been a perfect choice to also explore its usage for high performance computing. But what has exactly triggered this thing is, few years back, if you wanted to go ahead and get a ARM based machine or processor, then you'll probably have to go and get it directly, buy it from market, okay, and which was a costly affair that way. But in last couple of years, lot of cloud providers started providing ARM based instance. For example, Huawei Huawei Cloud do provide ARM instances through its high silicon Kunpeng 920. Amazon do provide ARM instances through Amazon Graviton 2. Oracle also announced that they will be providing ARM instances through Ampere Ultra. The instances are also available through Packet.com. So that easy availability of ARM instances through different cloud providers just made it easy for end user to go ahead and start booting them up. It also helps because like developers would in most cases, let's say developer could boot the things, but then what about the users? Now the complete both the user side and developer side can easily boot the instances on cloud and start harvesting the power of ARM. It is not only limited to that, but in fact, in past couple of years also, all major OS vendors have now port for ARM. So it's so all the basic packages you need are also being made available on ARM, and there are multiple projects being ported to ARM. Now, recently, sometime back this year, Hadoop made an official release on ARM. So that actually opened up a way for all the Hadoop-based project to now start supporting ARM. Now, databases we all will also see about them, but most of the open source major database are already supported on ARM. Then load balancers, application servers. See, also, it is very important to understand that ARM, the key motivation behind this is that ARM cloud instance has potential to generate around 30% of cost saving. And another important key point is, see, a lot of data generating devices are already on ARM. So having a data processing devices also on ARM help mark the circuit complete. So you can have everything moved to the ARM, a complete end-to-end solution being ported or run on ARM and achieve a significant saving by running everything in a single environment. So with that, let's understand this is a typical question most of the user has, that ARM is there for quite some time, then why is it taking so long for software to port to ARM? Now, ARM is also a little Indian, so if you take a software which works on x86, let's say, and you try to compile it on ARM, with pretty good probability it will get compiled and you will also be able to run it on ARM. The problem is, if you want to get the best possible performance out of this software, then of course there are few tuning that needs to be done. And these are the challenges we call for any software to get optimal performance on ARM. And why is that? Because ARM is a weaker memory model as against the stronger memory model that x86 has. Also, there are a lot of low level codes which have been typically tuned for x86, for example, timers, spin loops, and all. So, that also needs to get tuned for ARM. Now, ARM is all about more cores. So when it comes to more cores, your software should able to actually harvest a power of these more cores. So typically it is by using the parallelism, and also along with more cores, nowadays we get more NUMA nodes. So software should also understand that, okay, well, there should be a as much as possible a less or limit the cross NUMA access, because cross NUMA access has its own latency. Beyond that, there are times when you want to use the hardware instructions. These are low level hardware instructions, so most of these hardware instructions would be, if the software is made compatible or been tuned for x86, they would be x86 compatible. For ARM, these instructions are different because instruction set is different. So making sure that these instructions are also used is important. And ARM do offer a neon library, which is their parallelization library. So that facility could also be exploited. Now, of course, there are other cache line branching pipeline differences. Those needs to be understood, and accordingly, the things needs to be tuned. So fortunately, most of the open source database have been working on these aspects for more or less to some level, and because of which we, of course, we will say we are getting a better performance. Maybe it's not the best optimal performance, but we are getting a pretty decent performance, and of course, we'll see them to the numbers. So with that, let's understand open source database and their presence on ARM. Now, of course, this is not the complete picture of all the open source database that are present on ARM, but we are primarily considering the leading and the databases and something which is of more of our interest. For example, MariaDB, MySQL, PostgreSQL, MongoDB, and Percona server. Majority of them already have official packages on ARM. But let's understand what is the state of each of these database. So typically, when a user would like to move from one DB system to other DB system or environment or setup, whatever you call it, user would like to think it that okay, am I going to lose anything? Especially, user will evaluate the system in form of like what are the pros and what are the cons. And I would say it is easier if we can actually look it from these four perspective, and that should able to help ease out the process of whether it is the right thing to move from one DB setup to other DB setup. So feature set, performance, ecosystem, community support. Let's understand what we mean by each of them. So when I say feature set, it means that am I going to lose on any feature just by moving from my existing setup to a new DB setup? In our case, this is on ARM. Sorry. Performance, of course, no one wants to lose on performance, and so that's another aspect, right? Am I going to lose on performance, or would my software scale in the same way as it was scaling with my existing DB setup? Ecosystem, so as I said, database is never a standalone component. It has a lot of other surrounding component, and that makes it a complete DB system. Now whether it's a backup, monitoring, load balancers, whole lot of other things. So it's important to ensure that when a database is moved to a new setup, all these components are also made available on that particular environment too. And the last is the community support. So this is one of the major thing for open source project. And so typical the reason why open source projects are so successful has been because of the community that it has along with it. So let's say typical, if you have in a question, you would post it onto the community, and there will be a lot of people who would blog about it and who will write about things. But if you still if you post it in the community, there would be people who would respond back to you if they have encountered something similar or so. So that has been, so that community support is very important when you want to consider moving on to the new environment. So let's understand what is the state of different databases by looking at from these four perspectives. So if you talk about MySQL, MySQL have been releasing packages on ARM starting 8.x. So MySQL have official packages for um, for ARM with 8.x. Also, MySQL is feature complete. We are not aware of any feature that has been marked beta or experimental for ARM. Recent efforts has been done by MySQL side to accept some of the community patches, and most of these are performance patches, and they will help improve the performance of MySQL on ARM. But a lot of more patches are still in the queue. We are happy, like a lot of changes that MySQL has been doing are considering that there will be a that the MySQL has to cater or have to be run on more number of cores, so it has to be scalable that way. So like use of distributed counters, which actually limits or which is meant or designed in such a way that it adopts to the multi-core, multi-NUMA or more NUMA architecture is important. Bugs will be addressed or already getting addressed with the same priority like the other architecture. And in fact, since MySQL do support it, you can expect a pretty priority, the same priority for other architecture. Now supporting tools wise also, MySQL actually have done pretty good things. So MySQL router, MySQL shell connectors, all these things are also available on ARM. And there is also a dedicated MySQL and ARM channel on MySQL community Slack. So you can of course connect to that and post your question, and someone from the community would surely answer back to you. So overall, I think MySQL is in a pretty good state when it comes to ARM. Now let's talk about MariaDB. So MariaDB also have official packages on ARM. Again, it is feature complete. We are not aware of any feature that has been marked beta or even experimental for ARM. In fact, MariaDB is a forerunner in optimizing this database on ARM. So they have already accepted a lot of patches from community. They have already did their own self development, and now I think MariaDB, we can say, is pretty optimized for ARM. And that not only that, even their recent efforts or the new development that they are trying to do for normal MariaDB server, they do consider ARM as one of their target, and they do evaluate the new development on ARM through community support. Where they do lack is the tools which MariaDB has beyond the server, like MaxScale, which is their load balancer, or the connectors, are not yet ported to ARM. So getting them would also help, get the other part of the ecosystem complete. Uh, there is support for distro for most of the flavors of CentOS and Ubuntu's are supported, but beyond that, there are more distros, and we know that MariaDB has been working on adding support for more distros, so we can expect more distro support getting added by year end. MariaDB to have a dedicated MariaDB on ARM channel on MariaDB community Zulip chat. Percona server. So Percona server don't yet officially have packages on ARM, but it is community evaluated. I myself have tried it and it works on ARM. In fact, it is one of the widely used by community when it comes to MySQL, and it has been tried on varied architecture of ARM or varied ARM hardwares. Also, a Percona server is fully upstream compatible, and that means changes or fixes done by upstream for ARM will, of course, be inherited by Percona server default. Percona server has a pretty good number of supporting tools with the extra backup, PMM, which is their monitoring tool, Percona toolkits, and all of them works on ARM. Again, they have been community evaluated or sometime even Percona engineer evaluated. So I think that is a very good state to be in. Now let's talk about PostgreSQL. Now Postgres also has official packages on ARM through their Postgres repo. It is also feature complete. Postgres is also open to accept ARM patches. Already for some ARM, there are already some ARM optimizations that Postgres has already accepted. They also have a pretty active community, and which is gain and ARM in general has been gaining good traction there too. It scale inline like other architectures. So we'll of course see the numbers of how ARM scales. And Postgres ecosystem in general is a multi-vendor ecosystem. So a lot of tools comes from different vendors. But when we tried looking at some of the important and major tool, we found that most of them are available on ARM. Also, would like to make a note that there are some tools which are available directly from the Postgres repo, and there are few tools which are also available from the respective OS distro or basically OS repo made available on ARM. So it's pretty much possible that whatever tools you like, if you probably look for it, maybe from these two repos, Postgres repo or OS repo, you would find it available on ARM. MongoDB. So MongoDB also have official packages on ARM. It is a feature complete as per our reading. It again scale in line with other architectures or like other architectures also on ARM. And some of the ecosystem tools are also available on ARM. For example, the MongoDB database tools. So with that, let's try to understand, sorry, the ecosystem or evolving ecosystem on ARM. So when I say ecosystem, it effectively means if a user would like to move on to for a different DB setup, then are the remaining component, the way we said, are made available on ARM. So we have considered a couple of examples. This is the example of MySQL. So of course we know that server is available on ARM. But if you talk about other things, for example, HA solution, so whether it's a binlog replication or DB cluster, they are inherent to MySQL. So since MySQL server is available on ARM, these are coming along with it. For backup, you can always use Percona Extra Backup. It works on ARM. Uh, on for load balancer front, ProxySQL started offering official packages on ARM just couple of months back. MySQL router have official packages on ARM. PMM or Percona monitoring and management, again it's community evaluated and we know it works on ARM. Connectors official packages are available on ARM. DB tools, now toolkits, it works on ARM. MySQL shell, the packages are available on ARM. So if you look at from every category, one or two software at least are available on ARM, and all of these softwares are all open source. So if I want to do a transition to ARM using only open source software, then of course all of it's you will be able to find all kind of software or from all varieties or all categories. In all the categories, you will be able to find one or two softwares which are available on ARM. So that means you are not going to lose anything. You will be able to still function in the same way. And most of the software we have considered are the most common software that a user may be using. Beyond that, even the environmental tools, if you have been using MySQL instances to like Kubernetes, Docker Swarm, or using some kind of orchestration way of doing it, then most of those kind of products are also available on ARM. So that means we can have a full stack using open source software made available or enabled on ARM. In same way, if we look at Postgres, then Postgres server, of course, is available on ARM. On HA front, Rep Manager, PG Pool 2 are also available on ARM. Backrest or PG Backrest is also again available there. PG Bouncer, which is load balancer, is available. Monitoring, we talked about PMM. PG Admin is also available. Connector is also are also available. DB tool, whether it's PG Loader or PostGIS, are also available. On the environmental front too, again, if you are using that, then as I said, Kubernetes, Docker Swarms are already there. So we can also say from that okay, we could also enable a Postgres based ecosystem on ARM. Now if maybe if you feel okay, so I have not captured all the possible software, there would be more software which are available on ARM. Just captured part of them. And but the good part is this list is expanding. So let's say you have 10 software in certain categories. Maybe currently 2 3 5 softwares are made available, and in due course of time, the way the things has caught up the pace and the traction, and vendors getting interested, in I'm sure in another few months, if certain software is not available, it will surely be made available on ARM. So the important point is whether it is MySQL or Postgres or probably MongoDB, this ecosystem itself is growing, and you will not feel that okay, by just moving on from to ARM, am I losing something, because most of the more popular softwares or tools that you are used to are already available or getting available on ARM. Also, as I said, more databases and tools are getting added. Community is expanding. This is very important. So pretty good traction has been seen in the community, and a lot of new users are joining the community. And every that's like users not only users but developers are also present, so the community as such is expanding. Also, one good thing that happened in the past couple of months is Apple introduced M1, which is their first ARM chip for the laptops. And now your laptops or the Apple users will, whenever they move on to this new thing, will have a ARM based desktop at their place, and that will further accelerate the development, because they could try a lot of things, and it would be, further fuel the ARM adoption. Cloud offering is getting traction from enterprise users too. So so if you most of the softwares, I'm sure you'll be using open source, but if you have a specific software which is probably enterprise only, then of course yes, they are also, so enterprise users are also considering moving some of those things to ARM. And vendors are getting more and more interested, so they will be supporting more things on ARM. Vendors are getting interested to port their software on ARM, given the growing user base and the community is expanding, and the kind of course, the motivation that ARM provides from the performance and the cost perspective. A quick word on the migration. So, as I said, ARM is a little Indian. So, typically, if you look at, there is nothing no, major in terms of, or a major thing that is involved when you migrate from x86 to ARM. So, typically, when you upgrade or want to add an extra server, to your x86 cluster, probably you boot the server, you allow it to catch up, you make it slave, you allow it to catch up, and eventually maybe you will make it a master. And that's that simple steps you follow. And I don't think the steps are almost same when you think of ARM. So you could probably add an ARM instance, make it a slave, allow it to catch up, and some fine day you can turn it into master, and everything will work fine. Importantly, there is no MySQL. See, basically for this technology to work, it is all DB replication protocol. It has nothing to do with the processor. So that replication protocol is a processor independent. So from that sense, it is just like adding an extra machine to a cluster. Now whether it is coming from x86 or ARM doesn't matter. On tool front too, lot of tools, as I said, are already ported to ARM, and they do have official packages. They works on ARM. In fact, if you say that some certain particular tool is still not available on ARM, you can still continue to use it on x86 till it is made available on ARM, because anyway they do talk underlining DB protocol, and they are nothing to do with the processor, underlining processor that is being used. Orchestration wise also, you can do mix and match of instances on Docker, VM, bare metal. We have been personally trying some of these combinations, running few things on Dockers, and maybe running it on Docker, sorry, MySQL instances on x86, on Docker instances, and then using Docker images, and running and connecting it to a cluster for with ARM VMs. So all that kind of mix and match works fine. And there's nothing like okay, just because it's a different hardware at the underline, there is a problem. There has to be some special steps that you have to take. It just work harmoniously together. Now let's talk about the most important topic, that is the performance and cost. So, as you are aware, ARM is cheaper. This is a quick picture where we tried representing. This is from different cloud providers. So, if you try to consider it from, for the same flavor, if you try to boot an instance of ARM and x86, you would discover that ARM is always cheaper than x86. Of course, the range will vary, but you can surely expect around 30% saving for ARM. Let's understand this better using a simple data point. For example, on Huawei Cloud for 3500 USD yearly, you could get x86 VM, which will have 12 vCPUs and 48 GB of memory. For same cost, you would get 24 vCPU of ARMs and 48 GB of memory. So same amount of memory, but more number of cores. And in almost that effectively means also almost double the computing power. So that is the that is the your saving, or that you can expect from ARM. For same cost, you are getting double the computing power. Now, if your software is able to use this extra computing power and give you more performance, then you can say that I have achieved a cost saving, because for same perform cost I have invested, just by moving on to ARM, I am getting more performance. So we have actually we tag it as part this particular thing as cost performance model. We will You can read more details about it here, but the key idea is by keeping the cost constant and all other configurations and resources constant, and only allowing uh, computational power to differ, we will try to compare ARM against x86. This is just to get an idea as to that by keeping the cost constant, if you get the extra computational power, is that really helpful? Okay, and we'll see with those things with some numbers. But why CPM? That was the question most of the time we get, and the important point is, uh, see CPM. Sorry, if you talk about x86 and ARM, they if you try to compare them, it could not be a direct apple to apple comparison, because there are different processor generation, there are frequency differences, there are hyper threading, and versus ARM doesn't have this concept of hyper threading. And now Intel or x86 has turbo modes. And then there are NUMA arrangement differences. So with growing number of cores, maybe x86 you may have two cores, sorry, two NUMA nodes, but then for the same cost, you probably will get so many cores in ARM that you may have four core NUMA nodes. So all these things are different. So it is better that we keep the cost constant, allow the computational configuration to change as per the by keeping the cost constant, and let's keep the other parameters constant. And let's see if software could get us better improvement through that. So we have benchmarked MySQL using Sysbench and PGSQL using PGBench, and this is a typical how our workload is. So we have considered CPU bound, IO bound workload, all five cases of Sysbench, and of course I have not quoted PGBench, but the three cases of PGBench and machine configuration. So if you look at here, for the same cost, so we have kept the cost constant. So for the same cost, we are getting 28 vCPU of x86, and we are for the same cost we are getting 64 vCPU of ARM. That is 2.25x more cores or vCPUs of ARM. And of course the memory is constant and storage is also the same for both the machines. So now that extra computational power that we got, let's see if, if the databases are able to use it. So these are results with MySQL 8.0.21. Now this is with uniform. So if you are aware of Sysbench, the uniform means that it will touch majority of the data and lot of IO would be done. And of course this is with CPU bound. So that means the complete data set is in memory. And as you could see here, the blue line represent ARM and the red line represent x86. And uh, it's pretty much evident that ARM continue to beat x86, especially once the certain scalability point is crossed. ARM continue to significantly beat x86, and in some point the difference is almost 2x. In fact, for read-write workload, ARM continue to beat x86 even with lower scalability. But for read-only workload, once certain scalability point is crossed, ARM is beating x86. Now that is uniform IO bound. So when I say IO bound, that means not complete data is not in memory. So there would be a lot of IO, and even in this particular use case, you could see that ARM scores above x86. The other is Ziphian. Now Ziphian is the pattern will touch only the part of the data. That means only a part of the data will be touched, but that also means that there is a more contention. So uniform was lesser contention, Ziphian was more contention. So let's understand whether with more contention can ARM score. And as you could see, ARM is consistently able to score even with more contentions. And this is Ziphian CPU bound, and now we have Ziphian IO bound, where Ziphian IO bound 2 ARM is able to consistently beat x86. And this is TPCC, a different kind of workload. And again here too, with growing scalability, ARM is able to beat x86. In fact, for higher scalability, the difference is almost 2x. Now that's Percona server. So Percona server 2, this is again uniform CPU bound. Uh, consistently beat x86, and that's MariaDB 10.5.8. And again, the same pattern is observed. A significant difference is observed between ARM performance and x86 performance. And this is Postgres SQL. So PostgreSQL for select, no doubt, ARM is able to beat x86 after the scalability point is crossed. For simple update and TPCB, we have two graphs. One is the blue line, which is the baseline, and one is the ARM patch. So you could see that the baseline thing, for higher scalability, ARM actually falls down, and that was because there was a bottleneck, and patch for it is already submitted. If the patch get accepted, and we are very hopeful about it because it improves the performance in pretty good range, roughly 40% or so, for higher scalability. You could see how the graph getting corrected by following the green dotted line, and you could see that with the patch thing, ARM is able to beat x86 even for the higher scalability. So what all these things mean? We say that okay, well, ARM is getting you more TPS. So if you put it in other words, this is a simple data point I got. Effectively, what you are getting is for the same cost, you are getting more TPS, and that effectively means your TPS per USD is more with ARM. For a simple example, we considered this is like MySQL again 8.0.21 uniform CPU bound. You could see the TPS per USD is 42% higher with ARM. So for the same cost, you are getting 42% more TPS. In fact, it is further higher. We've considered one data point, but 42% more TPS. And another way you can say that I have got a cost saving of 42%. So it is more TPS at same cost. Let's understand it from another perspective. See, when you hit a problem like your scalability issues, then what probably you can think of is like, okay, I need a more TPS. Then the traditional approach is go get better newer hardware. But of course, these newer hardware or extra cores will come at extra cost. But now you have a solution where you can say switch to ARM, same cost. So you don't invest more, you pay the same amount of things, just same database, same environment, nothing changes except the processor, and you just get more performance. And of course, some of the users were wanted to interested to see what happens if you try to compare ARM by an x86 by giving the same computational power. And of course, here what we did is instead of keeping the cost constant, we kept the uh, sorry, we kept the computational and power constant, and of course the other components or other parameter remain constant, and we allowed the cost to differ. So the saving could be immediately realized. Of course ARM is cheaper than x86. So we, as you could see, x86 we have given 64 vCPU, and ARM2 also we have given 64 vCPU. Other configuration more or less remain the same amount of RAM, same amount or same kind of storage. Now let's see if ARM is really powerful. It will be able to also beat x86 with the same number of vCPU. And yes, it does. This would be a surprise to some of you, but this is with MySQL 8.0.22. This is something which we recently evaluated, so we have used the latest GA. And as you could see, ARM is able to beat x86 for higher scalability. For lower scalability, maybe it is lagging, but once it crosses a certain scalability point, ARM just scales better, and it is able to beat x86 for higher scalability. In fact, for update and update non-index use case, it is able to beat x86 even with a lower scalability. Except the read write. Someone would say that, well, I see a small curve where on for higher scalability too, where x86 is better than ARM. And I would say yes, that gap is like a 12% gap. And there are already, so this is like not MySQL is not, I would say, best optimal tuned for ARM. There are a lot of patches that are still waiting. And when we did so when we did we just applied couple of patches, and we could reduce that gap from 12% to 6%. And there are more such patches. So as and when MySQL do start accepting patches and start integrating them, this gap is further going to reduce, and I'm sure that ARM will cross x86. But if you just keep that thing aside for other four use case, even now without all the patches integrated, you can see that ARM is consistently able to beat x86 for higher scalability. So that is like for the same computing power but lesser cost, ARM continues to beat x86. So this is the message that is coming up. Any flavor. Now it's MySQL, Percona, MariaDB, PGSQL, any workload, CPU or IO bound, any pattern, read only, read write, any configuration, contention, non-contentions, any setup, single node, multi-node. Now we also saw cost constant and compute constant. So whether you consider a cost constant like the CPM way, or you consider the compute constant, one which we just saw recently. The message is very clear. ARM always score. See, ARM is not meant for certain workload or certain kind of applications only. ARM is meant to help you across the board. So whatever is your configuration, whatever is your low workload, whatever database you are using, whatever setups you have, ARM is always going to score. Let's talk about community. So as I said, community, there is pretty active community and it is expanding. More and more users are getting added to the DB on ARM community. MySQL have itself has 30 plus community proposed performance patches. MDB has also got a lot of community contributions, and most of them MDB or MariaDB has already folded. Percona tools, given their popularity, community has already evaluated them against ARM, and community by probably trying them with different combinations. And so PGSQL too have started seeing traction where community have started contributing patches and all. And the community, which consists of users and developers, it's like actually growing, and it is across the globe. It is not growing only like that okay, certain people who are interested are just doing it. It across the globe, everyone probably wants to try it. And what good thing has happened up is like, see, ARM itself is a open has an open model, right? So ARM has its own open ARM also has its own ecosystem, and it also has its own community. So some point in time, let's say you are not able to find a quick solution to some problem which you are facing, you can of course also check it out with the ARM community. And ARM itself also carry its own sub community. With Android has its own big community, now Apple community joining in. So ARM in general as an ecosystem or community is just going to grow. And it is already, we see a lot of good traction on DB on ARM community kind of thing. So the way we evaluated, like so we have evaluated all these things on the four main parameters, and you could see all of these databases have been able to qualify on all of the four parameters. So we can actually say that pretty much we can start considering ARM from the perspective of these four parameters, and all the needed things are available if user think of moving to the new DB setup. Future work. Now, a quick word about future work. So, vendor community continue to work on more tools. Now, of course, server optimization is a mainline focus, but optimizations of tools is also important. So that is also being worked out. More performance patches will continue. Feature that could exploit more cores. Especially parallel query or so. They mainly are meant for more cores. That would also help improving distro support. We talked about it that we probably the distro will be expanded further. Support for supporting tools like shredding or Kubernetes operator and all. More open source database. We just consider few of them, but more databases will get added, and more storage engine support. Like for example, S3. We recently tried it, and it does work. With but of course it is marked beta sorry gamma or alpha quality, something of that sort. It's not in GA by MariaDB, but we tried it with ERM and it is working. And columnar storage and RocksDB and all, so all of these things. So there are, so this is where we feel that the future. So a lot of good things are planned. The things are just going to get better and better. More, you could harvest, you expect more better performance, more better functionality from ARM. So with that, let's throw open the session for Q&A. Of course, before that, you can remain connected. You can read more about MySQL and ARM through the blog, and you can also follow or join the Slack channel. These are MySQL on ARM and MariaDB on ARM. You can reach me on email and follow me on Twitter and LinkedIn. And before we end out, thanks organizers and sponsor for making this possible and providing opportunity to share the ideas. Thank you.
All right. Thank you, Krunal Bauskar, for signing up for MinervaDB Athena 2020. Good to talk to you. Great, talking to the database performance engineers is every day something new, a lot of information for the community. I tell you why, right? One is the ISVs who makes optimizer more faster. Like for example, if you take the case of MySQL 8 histogram is giving an alternative thought for indexes, how indexes work. Same is for the PostgreSQL 13. They have advanced indexing methods which does parallel vacuuming of the indexes created. So if you look at ISVs are on a very aggressive space of making database infrastructure more fault tolerant or pardoning, more tolerant actually, right? Now when it comes to talking to someone who comes from the infrastructure point, right? You are making an infrastructure which is built for faster computing. Like when you're talking about ARM, right? ARM computing infrastructure. Something which comes first to each of the production engineers or data SRE, including me, is like, look, if I'm doing 60,000 transactions per minute on a processor, then processing infrastructure, then it's going to be 3x or 5x on a different scale. Can you share us like how do I use um, um, old school capacity planning metrics as a yardstick to measure the benchmarking of an ARM computing?
Sure. So the two aspect we will try to consider when we talk about ARM benchmarking. As you know, ARM is all about cheaper in terms of the performance per watt is better with ARM, and from that sense, the ownership cost of ARM is also less. So if you look at all the cloud providers who offer ARM instances, ARM instance is cheaper by a range of at least 30% when you boot same class of instance against x86. So if you want to go and measure it, so we can look it from both perspective. One is we can keep a cost constant and we could fetch out the extra cores or basically the extra computing power that we get from ARM. And of course, your software, if it is tuned, fortunately MySQL, MariaDB, all these things are already tuned, so they can harvest the extra power because they are actually meant to, or they have started getting developed for handling more number of cores, right? So in a sense, you just take your software, run it on ARM, and you could see the impact of around more than 30-40%, and in some cases it is like almost 100% benefit in terms of TPS you could see by just because there is an extra computing power coming up. And if you want to say that, okay, well, I want to, and of course it is a cost saving because you are getting more TPS for the same cost, right? And but then part of the time you would say like, well, I want to keep the same configuration just to compare. And even there, ARM is hits or basically scores are for x86, especially with higher scalability. So ARM continue to scale way better than x86 when it goes to higher scalability, even if both of them are using the same number of cores, or basically what we call as vCPUs. So I think it's pretty straightforward. You just pick a software, run it, and you will see that the TPS number will start to scale with ARM. But of course, what you need to do is you need to just make sure that you allow it to cross the scaling point. As in, maybe for lower scalability, x86 will surely scale because of the turbo mode and all. And but once it crosses that scalability point, you will see ARM continue to scale on all use cases.
All right, understood. So when you're talking from an infrastructure point of view, right? When you have built already a RAID infrastructure for your database operations, now you are moving to ARM definitely for performance. Now, database systems has got its own orchestration layer for the maintenance operations and management and automation and everything, right? Do you see from an ARM engineering or ARM infrastructure production engineering perspective, like something extra will come over? Like, actually, where is the complexity for me? Let's consider a case that there are some piece of my data is in bare metal, which is on ARM powered infrastructure, and some part of it is going to be again on a private cloud with and without ARM, right? So when we all bundle this as a single infrastructure, a single cluster of database infrastructure, right? That means building an orchestration or a management layer on top of it comes with a lot of tools from both the ecosystem. What do you have seen in the production life? How do they manage from a infrastructure operations perspective?
So, since this orchestration layer anyway is above, and ARM do support or basically this, all kind of orchestrations, which, for example, Dockers or Kubernetes and all are already there. So there shouldn't be issue what underlining hardware the orchestration is using. And importantly anyway, if you have two different instances probably running, we have use cases where few things are running on x86 and few things are running on ARM, because maybe customer is in a transitional state and wants to first make sure that things works on ARM. And the communication between the two machines anyway is the normal MySQL protocol. So that doesn't get affected. And orchestration layer anyway is independent of the architecture, so that also doesn't get affected. And in terms of complete ecosystem from orchestration perspective, so almost all vendors especially whether it comes to Kubernetes, Docker, Swarm or so, they have been providing all the ports for ARMs, and that's probably should able to take care of all the differences if in case there are any with respect to manageability aspect.
So what do you see? You see more of a hybrid computing infrastructure where ARM takes care of faster transaction processing system, and maybe the older archive data is going to the x86 infrastructure. How do you see this whole ecosystem working? Like, who you see as the ARM's most beneficial data property owners? I'm not talking about industry per se. I'm saying like which part of their business is coming to ARM and which part of that is not coming to ARM. Like, for example, is there someone who is using a columnar store infrastructure, be it like a ClickHouse or MariaDB columnar store, they're not using ARM, or people are in the transaction computing space who are on InnoDB or RocksDB, they're using ARM in a big scale. What do you see is the ratio? What do you see is the difference? Or who is
Well,
benefiting most?
most of the at least based on my reading and based on what I have got exposure to, most of the thing we are seeing is in fact lot of large customers who actually needs a lot of more computational powers or a huge amount of data, whether it's in form of big data or even in databases. They wanted to move to ARM, and of course there is a motivation because ARMs are cheaper. So if I'm going to boot like 1000 VMs versus booting them the same 1000 VM on x86, I could see a substantial difference. But if I'm a small shop, let's say I'm booting like one or two VMs, and then I would say that okay, I don't care, I am okay with x86, I just pay a few $100 extra. But when it goes to 1000, then it becomes 100K, and that's a significant saving. And in fact, the driving factor also beyond that is a lot of data generating devices has been ARM. Now whether you take IoT devices or for that matter all your cell phones, everything is on ARM. So if data generating are on ARM, then the data processing having them in the same ecosystem would just make them easy to integrate, right? We are talking about something like hybrid. So in a long run, maybe in short run you will see some kind of hybrid things because people are still getting used to ARM. And it is just couple of years back when ARM kind of a server class machines were introduced for high performance computing. But in long run, I am sure that a lot of customers who needs more computational power at a cheaper cost will surely come to ARM. And beyond that also, if you look at from an industrial perspective, I think all industry has this some way adoption for or link to the ARM. Okay, so it is not only limited to let's say HPC, but I would say all kind of industries wherever there is a need for data processing will have some kind of connect with ARM.
Perfect. So, do you like to share with us some instance or a story where customer had 100% x86 and they came to you? They definitely nobody go for a big bang infrastructure migration. You help them to identify what's going to be on a migration on a candidature, and from there you migrate maybe 30%, 40%. And what was the biggest challenge you face? Like, because if you see the migration get complex with the data volume size, right? If you look at typically any infrastructure migration, the challenge is like one, the transaction processing capacity on a higher side is a challenge. The resident data volume is another challenge. Three is like the migration transition processing, right? Migration transition processing. What I really mean by that is like at some point of time there is going to be a switch off going to happen to the to their existing transaction processing system, which is going to be on x86 to ARM. So how do you lay out a plan? Like someone who want to do a migration from x86 to ARM. maybe you have like 5 points, like you followed these 5 points, and this is like more of a I don't know, on a strategic perspective before the deployment.
So, of course, a lot of customers who would like to migrate, they would like first to try it out, right? So, I would say that is a preparatory phase where you probably set up a slave or, maybe a active master and allow them to play around. And that's where we have been trying with a lot of POCs kind of things. If we say, we internally have been trying to showcase some of the use case that how seamlessly you could actually have a hybrid thing. And this is mainly for the people who want to gain confidence that, okay, well, I can set this up and I can play it around, because no one wants
Mm-hmm.
to manually move the data. So
Mm-hmm.
whether it is in Docker, and some of the use cases that our team has tried up is like setting up sorry, servers on x86, and so on a Docker, and setting up a normal ARM based MySQL instance and trying to connect them, and challenges in terms of whether they are able to replicate. If there is an issue, we probably are trying to look at into those aspects. So we are kind of trying all possible combination a user probably could think of when they wants to. They probably will do this combinations and try it out. Now beyond that, of course, when a user think of moving out, of course I think it's going to be a simple, like for example, if I want to add an additional capacity to my x86 ecosystem itself, what I would probably do is like I will probably set up another instance and will start replicating. I think that is how simple moving to ARM would be. You probably boot up a machine, let it catch up, and one fine day you sit, just probably disconnect your x86 server, and ARM start pointing all your queries to ARM, and things should just work, because all of the things are from an outer user perspective, all are same. That nothing changes.
Mm-hmm. How do you see the performance difference when it happens on a higher right amplification storage engine, like a log structured merge tree storage engine, like RocksDB? Do you see the difference in x86, maybe a RocksDB and x86, sorry, ARM RocksDB? Do you want to do some comparison? What does like difference look like?
I personally haven't done it, but I saw community did that with MongoDB, and of course, when I say if you keep the cost constant, at least that's how the comparison was done. ARM continued to scale and continues consistently. I think was beating it by around 20 to 30% across the
Wow. Okay.
use cases for all the things. But for MySQL, of course, I have done that. So in terms of MySQL.
On in.
Yes, and it's on InnoDB. So I see that, as I said, right, not only keeping the cost constant, if you give the same number of CPUs or cores to ARM and to x86, it may come as sweet surprise to some of you, but then you will see that on ARM is able to scale consistently, and beat x86 with higher scalability, and that the percentage with some case is almost more than 40-50%.
Wow, wow, that's quite impressive. All right, that's all from me on MinervaDB Athena 2020
Thank
fireside
you.
chat.
Thank you
This
so
happened to
much.
be a virtual fireside chat. Thanks, man. Looking forward to hear more from you on ARM performance benchmarking. Like I mean, I regularly follow your blogs and you're publishing everything. Quite interesting, man. Follow you closely in the GitHub. Thank you so much for the commitment, what you show on the open source ecosystem. This really makes an encouragement and acceleration to the projects, man. Like this is quite interesting. Keep doing great work. It's
Thank
great
you so
talking to
much,
you.
and thanks,
Yeah.
all you guys for organizing this, giving this opportunity.
Thank you. Thank you,
Thank
man.
you.
Thank you.
Bye-bye.
Wishing you in advance Merry Christmas, a great 2021, where we can all go around, meet
Of course,
with
yeah.
like
Everyone is
people.
looking for years to change now.
Seriously, seriously,
Great,
man.
great.